In this PixInsight tutorial, I thought we would look at some of the hidden gems that some people never even realise are there. The first of which, in the processing sequence, is something called Muir Denoise. It's a script which is found under the script menu and noise reduction. And it's a very simple thing where you choose your image and the number of images in the stack, and then put the detector characteristics in these boxes here, leave these at default, and you hit denoise, and away it goes. The obvious question is, what do you put in here? And in the recent version of PixInsight, there is another script that allows you to calculate this from some standard calibration images. So I'm going to get rid of that for a second and bring up the script that helps you determine what your sensor settings are. And it's called Muir Denoise Detector Settings. And what you need is two uncalibrated flat frames. You need two bias or dark frames, which I've loaded onto the screen. And having done that, you hit Estimate. And the values you're particularly interested in are these down here. So a gain of just over 1 and a Gaussian noise of 26.3. So I'm just going to take a short note of that and then use that in the script. So I'm going to dismiss this dialog and I'm going to bring up an O3 image. Now typically narrowband are the most noisy because the signal is so weak, and if I zoom into double life size you can see the noise is fairly extreme. And keeping that in mind, I'm going to run the noise reduction script. So this O3 stack, what is the combination count? Well, if you don't know, one way to find out is to look at the FITS header for your particular image. And if you scroll down here, integration number of images equals 38. And in the most recent versions of the script, it automatically reads the FITS header and populates it. So going back to my script, 38 has been populated. The other thing that often is required for the best results is the interpolation method. Now what is that? Well, that is the setting that was used during the registration of images, because whilst you have individual pixels in each image, when it registers it registers on a sub-pixel basis and it interpolates to get the right results. So typically it's Lanczos 3. You can set it if you're doing a registration manually, but it's normally defaults to Lanczos 3. If you are concerned as to what it's used, then go back into your registered images and see what it says in the FITS header. Anyway, we've populated 1.1 or 107 to be exact. I don't think it makes a huge difference, and 26.33. Don't need an offset. I'll do a cycle spin count of 12, and I don't need to fiddle around backing it off. Again, the tooltips come up and it allows you to do things which are just fine tweaks. And I'm going to hit denoise. Now it'll take a little while, so I'm going to come back when that's finished. So, as with many scripts, the PixInsight interface is locked whilst it's running, so to do anything and to flip back to the previous state of the image, I need to dismiss the script. And if I toggle backwards and forwards, you can see it's made a dramatic difference to the noise level in the background. And if I scroll across to where some of the nebula is and undo it, you see that the structure of the nebula has not been affected. There still is that crispness, and it doesn't have any blurring effect on the nebula itself. So Muir Denoise, don't forget it. It's one of those things that you run immediately after the stacking process, before deconvolution or linear fit or any other linear processes. The second hidden gem is a utility that removes stars from an image, and it is remarkable in its effectiveness, and I tend to use it more than anything else than fiddling with morphological transformation, for instance. Now, it's not part of the standard PixInsight load at this point in time. It was generated, I think, by a user, and he's put it on SourceForge. So if you do a Google search for StarNet and PixInsight, you'll find a SourceForge link, and you can download it, and when you bring it into your downloads folder, it'll come up with a file, and there are a number of different parts of the file, and when you do the readme.txt, it will tell you how to install it, which is basically dropping the files into different folders on your directory. It's not installed, it doesn't come with an installer as such. And when you fire up PixInsight, then it appears under the Process tab here. It's right at the bottom, probably just off the screen, and it's called StarNet. And up it pops. And simply you apply it to the image. Now, I say simply because what you have to do to get the best results is to stretch the image first. Now, bearing in mind that one of the reasons that people use it is so that they can stretch narrowband images, such as this is, so that you can stretch the nebulosity without bloating the stars. So the trick here is just to do a very mild stretch, and I use histogram transformation, which we're very familiar with now, hopefully, and I'm going to reset it, take the screen stretch off, and just apply a mild stretch once. So a few stars have appeared and not much else. I'll do it a second time, and I got a very mild nebula and the stars have appeared. And that level of stretching is not severe, so it means I've got all to play for and I haven't bloated the stars. And all I do is apply it. The only tool setting really is this stride number. I've tried various numbers from 128 down to 16. Doesn't make a huge amount of difference. If you want to try out several times, you can always just drag your image off and create duplicates and try a different setting on each and see which one you like the best. But leaving it at the default 128, there's a second option, which is to create a star mask. And that's quite useful sometimes because you might want to, for instance, create a clone. With that checked and that clicked onto here, it'll leave the stars, and on this one, if you uncheck it, it'll take the stars out. So I'm going to apply this and come back in a while because it's fairly computationally intensive. So there you have it, stars gone. And just to see the effect, what is worthwhile doing is doing a screen stretch, and you'll see there are some small residuals where the stars were, and if we go to half life size, and if you start backtracking, you'll see the stars come and go, and yet the nebulosity stays exactly the same. If there are a couple of instances where the stars have caused a problem, then maybe some little residual, you could use the clone stamp just to get rid of what remains. And occasionally, when you have a really bright star that causes a bloat around it, that also sometimes around here, for instance, there was a star there, I'm betting. Yes, a brighter one. And occasionally that little glow there, when you stretch the image further, might become objectionable, and in which case the clone stamp might be the answer. The clone stamp is a bit like the tool of the same name in Photoshop, and it's under painting, because according to PixInsight it's heresy. And the way it works is you click on your image, choose a radius, not quite sure how big, and then you hit Command click and just pop in the stars there. And then when you're done, hit the tick button. And the reason you're doing this is because when you have very faint nebulosity, the extreme stretches that you apply to the image will cause those outer halos around the bright stars to bloat even more, and it just means that when you put it all back together again, you have some strange coloured artifacts. But hopefully those two tools have been quite useful, and again, when you just come back out again, it's just remarkable what it does. And this allows you to do the narrowband images that will be coming up shortly, where I want to take just the nebulosity information and manipulate that and put in the stars at the end. And if I tried to do it all with the stars in place, it would be very difficult indeed. So that's the second one. The next discovery is a tool that I've passed over accidentally for many years, and it has some remarkable properties that for some images could be extremely useful. On screen I've got two images of the familiar M45, and as the names at the top suggest, These are short exposures and long exposures, and as you can see with these screen stretches, that the long exposures show the background flux nebula quite well, but if I take out the screen stretch in both cases, you'll see that the stars have clipped to white on the prominent stars in the cluster, and even on this one, which was 1/10 of the exposure, it's still maxing out, but it's probably usable. So what I would normally do is combine these with the tool that's been looked at previously in the integration section in the process tab here, called HDR Composition. And what that does is it takes files and it blends them together with, when I expand the right section out, it's basically starting to blend them around the 3/4 of the range, and it pulls together a third file. So I'm just going to take out the 64-bit for the moment, and I'm going to hit apply, and it gives a result. And I've been using it for a number of images, typically the ones which have bright central cores on galaxies or nebulosity with extremely intense stars around them. And if I now click on that to do the screen stretch, you can see there's the image, which is reasonable, and you think that's wonderful. Well, I discovered another way of doing it with a very similarly named tool called Gradient HDR Composition. It's lurking down here, Gradient Domain, HDR Composition. And in the gradient section, the one I have used in the past has been the Gradient Merge Mosaic, which allows you to blend mosaic images together. But I've never used this one, which is Composition. As long as your image is cropped and there's no silly things around the outside, very similar to the other tool, if you just hit the default settings, add your files, and run it. This tool actually does have some documentation, remarkably. It does a lot more calculations, and I noticed the word Laplace in there, which has brought me out into a cold sweat because I used to do that at university many years ago. Anyway, it's produced a result, and you think, well, that result doesn't look anything particularly special, except that this one here has been screen stretched. So let's screen stretch this one as well. Now immediately you get a very different result, and what's very apparent on it is that you can see the interflux nebula around the back of this main nebulosity on the loose cluster, and it's far more distinct. And I was struggling to try and pull this out of the image by doing all kinds of weird processing, and it's here all the time. So that's my third little one. And if you notice also that the stars are much smaller in the middle than on this one, that's quite a nice result, and I'll be using that in future. It won't work in every instance. There are a couple of things. If you uncheck this keep in log scale on this particular image, it produces something absolutely awful. And there's a few other parameters, but in this case there is documentation, and you can scroll through the documentation and read up on it. It's worthwhile experimenting with it as an alternative. The last of these little videos is regarding getting the backgrounds looking right on images. I've quickly stacked blue, green and red files and done a dynamic background extraction on each and combined them into a colour image. If I screen stretch the colour image, you can see it's the familiar M45, and the background is still fairly yucky. So one of the things we can do here is to try and equalise the background. And there's a couple of little tools here, one we've seen before and one we've passed over very quickly. The eye is incredibly sensitive to green pixels, and it's one of the reasons that colour cameras have twice as many green filtered pixels on the sensors as they have red or blue. And the problem is that green really doesn't appear on its own as a colour in the night sky, apart from the one instance of the nebula of a comet. Now, one of the things that we can do is replace green pixels and replace them with a neutral result. And there's a little noise reduction utility called Selective Colour Noise Reduction, or SCNR, and its default settings bring up green because green's often the most dominant colour. And if you notice, this has got a slightly green hue. Now, it's not reducing the green content of the entire image, it's looking at pixels that are predominantly green and changing those. And very simply, you can drag it onto the image and it replaces the green pixels with an average neutral result. So your eyes adjust to the changing colour and it looks like the result is magenta. And to some extent it is. If you scan your eyes down to the bottom, you'll see that red is very slightly higher, 0.00493 versus 0.0048 and 489. So there is a marginal red hue here. And this is a good place to start now to try and remove the actual colour of the background and make it neutral. This image has got background nebulosity, and if you do the extreme stretch, which is the little radiation icon with an upward arrow, you can see not only a couple of small artifacts coming off the sensor, but you can see that there is some cloud structures here and a little bit of vignetting in the corners. So quite tricky in order to find an area to classify as background. But we're going to give it a go, and we're going to use another one of those little tools that can be quite handy. So we're going to select areas of the background by bringing in previews. So I'm going to bring in one here, and I'm going to bring one in this corner here, and I'm going to bring one over here, and I'm going to bring one in this corner here. I don't want to get too close to the blue nebulosity itself, and perhaps the last one here. This might not be the last word in placement of these previews, but it's the intent of it which is important. I want to use all these previews to act as the source of background information for the background neutralisation tool that we've used before. But normally you can only select one reference image. Well, fortunately there is a little script that combines all the previews so that you can create one overall preview that's split up over the image. And under Script and Utilities, it's called the Preview Aggregator. And it's already pre-selected automatically all the previews, which are all okay. And it's going to create a new preview. And there's my file. So that's my file of background levels. And if I sample the background level with my cursor and look at the bottom, all the values are below 0.006, which is good. So if I put in 0.006 in here, and in the reference image, pull up the aggregated, I can then shrink this down and apply it to the image. Now, because of the screen stretch, obviously the background suddenly changes, so I need to hit the screen stretch again and see the result. And overall the result's a lot better. That's certainly neutral there. There's still a tiny little bit of redness here, but overall the result's a lot better. And if I went back a few shades and hit the stack, you can see it's taken a lot of the red out of the background. You can also apply this to the opposite end of the spectrum, i.e. the highlights, and you could create previews that covered all the stars that hadn't saturated, and you could use that as a white reference, aggregate the previews and use it in the color calibration tool. So that's the last of these little video vignettes. Hope that's been useful, and in the next one we're going to start looking at narrowband imaging and some of the challenges that they present and the unique ways in which you deal with very dim exposures. Thanks for watching.